This unit looks at probability, starting at basic probability scale questions, working our way up to problem solving with combined probabilities. Okay, so let's start with our basic probabilities then. So a bag contains 4 red, 5 blue, 6 yellow. 1 bead is chosen at random. Write down the probability of choosing a red bead and then a blue or yellow bead. So first of all, let's just underline our key information. So we've got 4 red, 5 blue, 6 yellow. We know it's chosen at random, so nobody's looking. And then our instruction is to find the probability of choosing a red bead. Now, probabilities can be written as fractions, decimals, or percentages. They have to be less than 1 but greater than 0, with 0 being impossible and 1 being certain. So if we're going to choose a red bead, we have 4 red beads out of how many are there in total? Well, there's 15. So my probability of choosing a red bead is 4 over 15. The probability of choosing a blue or a yellow, well, there's 5 blue and 6 yellow, so there's 11 counters that I could pick from, again, out of 15. Okay, we've got a fair-sided 8-sided spinner. Jill's going to spin the spinner once. It'll land on one of the colours. Which colour is the spinner most likely to land on? Well, we can just look. We've got 1, 2, 3, 4, 5 reds. There's 2 blues and 1 green, so it's red. What's the probability it will land on a green? Well, there's one chance of getting it out of green, and then count 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8th. On the probability scale, mark down where with an X where it will land on green. So if we've got a half, we know that then that there would be a quarter roughly. So an 8th is about there. So we just need to mark on with an X there. So this time, what's the probability that the arrow will land on a prime number? So before we start, let's just make sure we know what prime numbers are. 1 is not prime, so our prime numbers are 2, 3, 5, 7, and so on. We've been asked to give our answer as a fraction, and this is telling us what to do it in its lowest terms. So the prime numbers on here are 2, 3, there's another 2 there, and a 5 there. So there are 4 prime numbers out of 6, which we can cancel down to 2/3. Now an odd number. So let's look for our odd numbers. Well, we've got 1 there, we have 1 there, and that's it. So we have 2 odd numbers. So there are 2 odd numbers out of 6, which cancels down to 1/3. Now square numbers. Our square numbers are 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, and so on. So the square numbers on here, we have a 4, and that's it. So we have 1 square number out of 6. Your turn. Pause the video, try these questions, and when you've done, press play to check your answer. Okay, let's check your answers then. So the answer to the first one is there are 10 out of 20, which cancels down to a half. The ball being blue is 8 out of 20, which cancels down to 2/5. The probability the ball is white is 2 out of 20, which cancels down to a 1/10. Which colour ball is most likely to be taken out? That one would be a red because there's more of them. Which colour ball is least likely to be taken out? That's white because there's only 2 of them. Calculate the probability the ball is yellow. Just 0. Calculate the probability that the ball is red, blue or white. That would be 20 out of 20, which is 1. Calculate the probability that the ball is not blue. Well, there are 12 balls in there which are not blue out of 20, which is 3/5. Now press pause and try section A from your workbook. Okay, the next thing we need to be able to do is calculate probabilities from a table. So if we have a coin that's tossed and a dice that's rolled at the same time, we want to list systematically, and that word systematically just means in an ordered way, all the possible outcomes. So here we go, we can see we could have a 1 with a head, a 2 with head, 3 with head, but this one would be 3 with a tail, 5 with a tail, and so on. What's the probability of getting a head and an odd number? So find all the ones where you've got a head and an odd number. So there's one, there, there, and that's it. Okay, so there are 3 ways out of the 12 possibilities of getting a head and an odd number. So that's a quarter. What's the probability of getting a tail and a prime number? If you remember from the last one, we said that our prime numbers are 2, 3, and 5, and so on, but we don't need to go above 5. So we're looking for ones with a tail and a prime number. So we have 2t, 3t, and 5t. So again, 3 out of 12 or a quarter. Okay, this type of table is called a two-way table. So we know that 10SC went abroad last year, and the table shows where they went, and we want to complete the table. Right, we're going to start with this row here, Europe, because we have 13 girls that went to Europe and 22 in total, which means that I know there must be 9 boys that went to Europe. And then if we move across to this row here, we know that there are 9 boys that went to Europe, 2 boys that went to America, and there needs to be 12 in total. So there's 1 missing there. We could do, this number here needs to be a 3 to make that row add up to 5. This row here now with the 18, we have 13 add 3, which is 16, so the rest of the world must be 2. And that must be a 3. And then this final box here is a good little check, because if we add up the 22, the 5 and the 3, I get 30. And then I can check as well that my 18 and 12 add up to 30 as well, which they do. One student is picked at random. Write down the probability the student visited America. Well, there are 5 students that visited America out of 30. Now that would cancel down to a 6th. Find the probability it's a girl who visited Europe. Well, there are 13 girls who visited Europe out of 30, and that won't cancel down. Your turn. 100 shoppers were asked to name their favourite flavour of crisps, and the results are shown. Pause the video and answer the questions, and then press play when you're ready to check. Okay, so first of all, let's put the totals in. So we've got 40 on the top and 60 on the female row, which means we've got a total of 100. And then we can put in our 35, 39 and 26. So the probability someone is male is 40 out of 100, or 2/5. A male who prefers plain crisps, so the males who prefer plain crisps, here, the 10 of them, out of 100, which is a 10th. A female who prefers cheese and onion crisps, so a female who prefers cheese and onion crisps, 20 out of 100, which is a 5th. Pause the video and try section B from your workbook. Okay, let's have a look at some relative frequency questions. Before we start though, it's useful to know that the total of all probabilities needs to add up to 1. So here we're given a table with some information about students' meal choices at lunchtime, and we're asked to find the probability that a student chooses meat pie. Well, we can get that straight off the table as 0.23. The probability a student chooses salad or fish would be 0.2 plus 0.16, which is 0.36. Now the probability a student chooses pizza, we're going to use the information that we know all those probabilities have to add up to 1. So we're going to add them up and take them away, which gives us 0.41. We have 4 teams, and the probabilities of each team winning are given in the table. Now notice here, this time though, we've got a 0.25, a P and a 3P. And we're asked to explain how St Patrick's and St Bartholomew's chances of winning compare. Well, St Patrick's have 3 times more chance of winning than St Bartholomew's. Now we want to find the value of P. Well, we know that those 3 values all have to add up to 1. So 0.25 plus P plus 3P has to equal 1. So we get 4P plus 0.25 equals 1. That means 4P must equal 0.75. So P, we divide it by 4, gives us 0.1875. Okay, let's have a look at this exam style question then, problem solving. A bag is filled with 40 coloured balls. So that's part of my key information. 15 of them are red. The probability that a ball picked at random is red or green is 0.7. So how many green balls are there? Well, I start off by knowing that 0.7 times 40 is 28. So I've got a 0.7 chance out of the 40 of getting a red or green ball. So of those, 15 are red, so there must be 13 green balls. Have I answered the question? The instruction was how many green balls, and I've said there are 13 green. Your turn. Pause the video, try these questions, and then press play when you're ready to check the answer. Okay, knowing that there are 52 cards in a pack is really important for the exam because they could ask you this without telling you that information. So the probability that Peter picks a heart, well, there are 13 hearts in a pack out of 52, which means there's a quarter. An ace, there's one ace in each suit, so there are 4 out of 52, which is 1 over 13. He doesn't pick a picture card. Well, the picture cards are Jack, Queen, King, so there are 3 of them in each suit, so there are 12 in total, which means they're not picture cards, there are 40 of them. So we get 10 out of 13. He picks a 10 or a Jack, so how many 10s are there? Well, there's 4 of them and there are 4 Jacks, so that's 8 out of 52, which is 2 over 13. He picks the ace of spades, there is only 1 ace of spades, so 1 out of 52. Now try section C from the workbook.